All right, let's talk about something really cool. We're not just looking at a new phone today. We're diving into a whole new way of thinking, and it's all happening right inside the phone itself. We're going to break down how the Pixel 10 Pro's on-device AI can actually anticipate what you need, sometimes before you even ask. Let's get right into it. So picture this. You're texting a friend to meet up, and boom, your phone just suggests the address you were literally about to go look for. Now that's not happening in the cloud. That is proactive, on-device AI. It's instant because your data never has to leave your phone, which also means it is completely private. And that is the revolution we're digging into today.
Okay, so here's the game plan. We'll start with what this actually feels like for you, the user. Then we're going to get nerdy and dive deep into the hardware, the Tensor G5 chip, and the software that makes it all sing, which is called LiteRT. After that, we'll unpack Google's kind of unique philosophy of stability over speed. And finally, we'll see how this pocket-sized AI is already changing entire industries.
First up, let's look at the star of the show from your perspective as a user, a feature Google is calling Magic Q. So what exactly is Magic Q? Well, think of it like an assistant that's actually paying attention to what you're doing. It's the thing that can pull an address from a recent email and pop it right into your message thread. And this is only possible because the AI models are running locally, right there on the phone. There's no waiting for a server, which means it's lightning fast and your data stays right where it belongs, with you. And here's how it has such a crazy good memory. The AI has what's called a 32,000 token context window. You can think of that like the AI's short-term memory. It's huge, enough for the phone to remember and cross-reference an entire month of your emails or hundreds of screenshots to find exactly what you need. That massive on-device memory is what makes its suggestions so personal and so spot on.
So, how in the world does the phone pull all this off without using the cloud? Well, the magic really starts with a custom-built silicon, the Tensor G5 chip.
Okay, this is probably the single biggest deal on the hardware side. For the very first time, Google has moved its chip manufacturing over to TSMC, and they're using their cutting-edge 3-nanometer process. This is an absolute game changer. It's the key that unlocks the heat and power issues that held back previous Pixels, and really, it's the foundation for everything else we're about to talk about. And this chart? Man, it really lays out the whole story. You can see a really nice 34% boost in average CPU performance, but look at the TPU, the Tensor Processing Unit. That is the dedicated AI brain of the chip, and it's up to 60% more powerful. This is where the heavy lifting for features like Magic Q really gets done. Okay, so what is a TPU, really? Imagine a normal CPU is like a master chef. It can cook anything. A TPU, on the other hand, is like a super specialized assembly line built to do just one thing, but to do it perfectly: the complex matrix math that powers AI. Data just flows through it in this perfectly synchronized wave, avoiding the bottlenecks you see in traditional chips. It's just incredibly fast and power efficient for these kinds of tasks. Look, having killer hardware is great, but it's only half the battle. You need a really sophisticated software layer to make it all work together, and that's where LiteRT comes in. You can think of it as the universal conductor that tells the entire AI orchestra how and when to play.
You know, back in the day, developers had to do all this manual, complicated coding just to tell an app which part of the chip to use for AI tasks. It was a headache. LiteRT's new system just throws all that out the window. It automatically looks at an AI task and assigns it to the best tool for the job, whether that's the super fast TPU, the GPU, or the CPU. It handles all that complex wiring behind the scenes so developers can just focus on building cool stuff.
So, for the folks actually building the apps, the whole process is now incredibly simple. It's basically 3 steps. First, their AI model gets pre-optimized specifically for the Tensor G5 chip before it even reaches your phone. Then, it gets delivered through the Play Store like any other app update. And finally, when you run the app, LiteRT takes over, making sure that the AI task, the actual moment of thinking, the inference, runs on the most efficient part of the chip. It's streamlined, it's reliable, and it's just so powerful.
All right, this next part is super interesting because it kind of goes against everything we think we know about tech. Google isn't actually trying to win the race for the highest benchmark scores. Nope, they're playing a totally different game, one that's focused on sustained performance. They're building a marathon runner, not a 100-meter sprinter.
And this chart right here, this tells the whole story. This is a performance stress test. See that competitor chip? It starts off like a rocket, sure, but look what happens when you push it. It overheats and throttles, dropping to less than half of its potential.
The Tensor G5, though, thanks to that new 3-nanometer process, just keeps going, maintaining over 95% of its performance. That's the key. Real-world AI isn't a short burst. It's a constant, demanding workload.
At the end of the day, it all comes down to this core philosophy. The phone is engineered for thermal stability over the long haul, not for short, flashy benchmark tests. It's about being able to run complex AI for hours without your phone turning into a hot brick and slowing to a crawl. That endurance, that's its real superpower.
Okay, so why do we care so much about this marathon runner thing? I mean, why does it matter? Well, because when a device is this stable and this powerful, it stops being just a phone. Let's zoom way out for a second and see how this same tactile edge architecture is being used in a really high-stakes industrial setting. So get this. This company, 905 Wood, has what they call a digital refinery. And what they're doing is using Pixel 10 Pros out in the field as these little portable on-device AI servers. Each phone is responsible for doing complex material analysis to make sure everything is safe, often in really tough conditions where there's no cell service for miles.
And this is where it all clicks. All that tech we just talked about, it's not just for cool features, it's mission critical here. They get instant, sub-2-second analysis because LiteRT is running the AI locally, no internet required. They can even push out what they call agentic safety alerts. These are notifications so important they can actually bypass a user's Do Not Disturb mode. And most importantly, that 8-hour thermal endurance, that's the 3nm Tensor G5 earning its keep, letting them run these AI scans all day without throttling. It literally turns a consumer smartphone into a piece of rugged industrial gear.
So what we're really witnessing here is a huge shift. For years, all the real AI power lived in these faraway data centers. Now it's being packed directly into the silicon that we carry around in our pockets every single day. From anticipating your next text to ensuring safety on an industrial site, we're just scratching the surface of what's possible. It really makes you wonder, right? As this incredible power becomes universal, what are the next big problems, big and small, that we're all going to solve?